The Fire Department Connection, or FDC, allows the fire department to connect an engine to the fire sprinkler system to supplement the municipal water supply. They may have connections in the form of multiple 2.5-inch inlets, or may have a single 4 or 5-inch stores or sexless coupling. On a single riser system, the FDC admits water to the system on the riser side of the main supply valve. This is done so that the interruption of a municipal water supply does not affect the fire sprinkler operation. If the system is a multiple riser system, water is introduced between the main supply valve and any floor or zone control valves. This is done so that the water can be distributed throughout the system even one floor or zone has been shut down. The wet system is the oldest and simplest system. Water, under pressure, is in the system at all times. However, they cannot be installed in freezing areas without some type of freeze protection. The alarm check valve and water flow indicator are valves that transmit an alarm when water flows through the system. They work in slightly different fashions that are described in the book. These systems tie into a local alarm and fire department notification system, minimizing fire and water damage and improving occupant safety. Antifreeze systems are used in wet pipe sprinkler systems that are exposed to freezing conditions. Dry pipe systems are systems that have air or nitrogen under pressure, replacing water in the pipes exposed to freezing temperatures. When the sprinkler head is activated, the air escapes the piping, allowing water to enter the system at the dry pipe valve. The dry pipe valves prevent the water from entering the system using the air pressure in the lines. If the dry pipe system is large, a quick opening device will reduce the reaction time that the system needs to evacuate the air, delivering water sooner to the fire. A deluge system is similar to a dry pipe system in that there is no water in the piping before activation. However, in a deluge system, all the heads are open. There is no heat detecting device in any of the heads. A fire is detected by a detection device, such as a smoke or flame detector, thereby activating the sprinkler system. These systems are designed to deliver a high volume of water to the protected area. They can be found in extra hazard areas such as aircraft hangars, woodworking shops, or ammunition storage. They also may be found in shopping malls where a division of occupancy is needed that can't be provided by firewalls. A pre-action system is used when it is important to minimize water damage. They may be found in computer rooms, document storage areas, or in freezers. These systems have closed heads, a fire detection device, and a deluge-type valve. The piping is dry, and water is not introduced until a signal is sent from a detection device. Single interlock system admits water to the system upon activation of a detection device. Non-interlock system admits water to the system when activation of a detection device or automatic sprinkler. Double interlock system admits water to the system upon operation of both a detection device and the automatic sprinkler. Modern warehouse design and storage practices have challenged sprinkler designers and firefighters alike. Furthermore, retail facilities are beginning to look more like warehouses that admit the public for shopping. The two primary challenges are simple: the size and layout of the building. Undivided areas coupled with high-piled storage create a very volatile environment. With the addition of shoppers, the risk is even greater. The classification of the commodities that are stored are one key component to determining the amount of sprinkler protection required. The considerations that are taken into account when classifying commodities are heat of combustion, rate of heat release, and rate of flame spread. The commodity consists of the product, the packaging, and packaging aids such as shock-absorbing materials.
An adequate sprinkler system is a key ingredient in fire protection. Tests have shown substantial differences in fires in sprinklered versus non-sprinklered structures. But if sprinklers can be that effective, Then why do sprinklered buildings burn? There are several reasons. One problem is design deficiencies in the water supply system. An adequate system should be designed for a particular occupancy, providing maximum water volume and pressure needed to fight fire for the most severely anticipated hazard. For example, paper products typically require less water for fire control than flammable liquids or aerosol storages. Additional materials provide an additional fire load and the potential for rapid fire spread. Knowing a facility's sprinkler system's limits and capabilities is an important aspect of pre-fire planning. If occupancy changes create exposures which are more hazardous than the previous occupancy, the sprinkler system's effectiveness may be severely reduced. Still, other factors may inhibit the effectiveness of sprinkler protection. First, there is the impairment to a system before a fire. The usual cause of an impairment is a partially closed or totally shut valve. Such improperly closed valves are usually a result of carelessness after routine maintenance or testing, or during building renovations. Remember, a fire may happen at any moment. By the time a sprinkler system can be restored to service, the unprotected facility has a greatly increased chance of devastating loss. Impairments are also caused by obstructions within the sprinkler piping system, such as rocks or other debris, preventing water flow to the fire location. When water can't discharge from heads over the fire grows, and its intense heat opens nearby heads, including those over areas unaffected by the obstruction. When a large number of heads operate, the water supply is very likely to be rapidly overtaxed. In operation, the sprinkler system is an ally to the firefighter. It's on the scene before the fire starts, and in many instances is the difference between a minor incident and an uncontrollable fire. Sometimes sprinkler impairment occurs during a fire because someone closes the valve, stopping water flow to the sprinklers. This premature valve closing is motivated by the following. First, the belief that shutting down sprinklers as soon as possible minimizes water damage. In reality, the water from an adequate sprinkler system is less than that from hose streams to control the same fire. Second, to increase visibility. When sprinklers are activated, their water cools the fire, protecting the roof and containing the flames. In so doing, it also drives the smoke downward into the seat of the fire. However, shutting off sprinklers may hasten heat release and fire spread. Therefore, it is rarely an advantage. It is extremely important that sprinklers continue to operate until the fire has been extinguished. While adequate sprinkler systems are extremely critical fire protection tools, it is essential to know how to best use them in fighting fire and minimizing loss.